From the critically sampled version, we can go back to the original time domain using the synthesis MDCT. So this is what we're looking now. This is the MDCT synthesis filter bank, and we want to achieve the perfect reconstruction. So what we are doing now is we are computing the inverse folding matrix for the synthesis, Fs, we are doing here. Then we are applying the inverse transform, for which the DCT4 is identical to the forward transform. We are applying the DCT4 inverse transform to the rows. We have here. Then we are calculating the inverse delay matrix with delay, which is here. Then we're multiplying the inverse delay matrix with delay, and we have this polymath mode that we've seen before. And then we are multiplying the synthesis folding matrix Fs with the Y of P, and then we have the X reconstructed P. So here it's a polyphase signal, and we are going to use polyphase to X to convert the polyphase input signal into a contiguous row vector. So this is what we are doing now. We have this X rec P, and we are applying this polyphase to X. Now, before we had X rec P with these dimensions, and then we convert from polyphase to X. We have this here, and here we can plot the original, which is in blue, and the reconstructed, which is in orange. And we see that there is a delay of 1024 samples. So if I introduce this 1024 samples, we have perfect reconstruction with this delay of 1024 samples between the original and the reconstruct signal, which is the system delay without the blocking delay, since the signal is already in memory. That's it for our tutorial. I hope it was useful, and don't forget to check out the sound, this double cross, and I hope to use much more of their songs in next tutorials.